Go back to this formula just for comparison so that we know what we're doing now. Okay. If you remember, arc price elasticity of demand, this is D, was equal to delta Q over mid Q, all of this divided by ratio. So delta P, mid P. Now, this is arc elasticity, yeah? Now, the next topic is the point elasticity. So they will have the same notations, however, the formulas are different. Here we have dQ over dP times P over Q. You see, this is a slightly different formula. This is point elasticity. Now, if we want to see this on a graph, assume this is our demand curve. Now, with arc elasticity of demand, we were interested in, let's say this is P1, this is Q1, and at this point, this is P2, this is Q2. We were interested in elasticity of this demand between these 2 points, A and B. With the new formula, with the new concept of point elasticity of demand, we are now interested in, at one of the points, the elasticity of demand at one of the points only. So we may pick point A, and we may ask, what is the point elasticity of demand at this point A when the price is P1 and quantity is Q1? You see the difference? So the formulas are completely different as a result. And in this case, we're looking at just one point on the curve. Now, question is, what are these? What is this expression here, dQ and dP? This is basically change. It measures the change in quantity demanded when price changes by a very, very tiny amount, infinitesimally small amount. And now this rings the bell, right, about derivatives. Yeah? This is basically derivative of Q, function Q, with respect to P, price. This is usually a measure of slope when you draw this. It's a measure of slope. It's a rate of change in calculus. It's a rate of change in y when x changes by a very small amount. So the same here. This function, this expression here, this ratio here, dq over dp, measures basically the rate of change in q, quantity demanded, when the price changes by a very small amount. So let's do something here. P, this is q. Let's do some example. There's an example in the slides here. Right, now let's take this example, measuring elasticity at a point. The formula I've put on board early is this one here. Price elasticity of demand, P epsilon D, or epsilon D itself, if you want, equals 1 over slope times P over Q, which is the same as the formula that I showed you earlier. It's just the terms in the brackets, that if you go back, I hope the video doesn't cut out if I just... So you see 1 over slope is basically the term in the brackets that I showed you earlier. So it's just a change in quantity when the price changes by a small amount. Now, using this formula, now we will be finding the point elasticity of demand at point R, at this point. At this point, we are given coordinates. Price is 30 pounds, quantity is 40 pounds. Now, we now have two terms here that you can plug in into this formula. P and Q is given at that point. P is 30, so we can plug that in. Q is 40. Now, how do we though find this term in the bracket? What's the value of the term in the bracket? So this is the last step. What we can do now is, we can, basically this term measures the rate of change in quantity when the price changes by a very small amount at point R. Now at this point, we don't know that. We don't know how to estimate this at this point. One way is to employ or use the concept from derivatives, from calculus, which we'll be doing next. Instead, what we do is, we now draw a tangency line which just kisses this graph at point R. So we will draw a line now, a straight line that kisses when I say kiss, touches it, goes tangent to point R, at point R here. So let's do that. This is the line. Now, assumption here is this. The slope of this line, tangent line, is the same as the slope of the D curve at point R. That's what we need. Because with the original demand curve, it's not easy to find the slope. We can now use the straight line to get the slope. And we know how to calculate the slope of a straight line, don't we? That's what we need here, slope, this value. So if we just plug that into this, we will be able to solve this equation, this problem. So can anyone remind us what, from your calculus class, the formula for calculating the slope of a straight line? How do we calculate the slope of a straight line? Yes, exactly. So in this case, y2 and y1 is what we need, and x2 and x1 what we need. So let's go back to this again, our drawing board. We have similar problem here with the y-axis so this is the price, and this is y, and this is the quantity, this is x. So this is x2, and the coordinates here are 0 and 50 for this point. Coordinates here are 100 and 0. So use that to calculate the slope. Once you do this, I'll go to the next stage. So can you calculate the slope for me, please? You should just get the slope by using the formula I've just showed you. You see, it's 50 and 100. You should get the same result as we did earlier. You should get minus 1 over 2 or minus 50 over 100. Plugging that value into this formula, we get now minus 150, 100 over 50 times price at point R is 30, quantity is 40, so they are all plugged in the formula nicely. Is this clear now, guys, where we are getting the values? If not, just stop me here and we go and do this again. So minus 100 over 50 is basically 1 over the slope. The slope was 50 over 100, so it just flips. Yeah, the numerator flips. So that you get then 100 over 50. Now P is the price, Q is the quantity we are given. If you just simplify it further, you get a negative 1.5, an elastic demand. Now, what we've just did is the elasticity of demand at point R with respect to price. You see, we are not given a points of change between two prices. So this is a point elasticity of demand estimation. Any question? No? Everything is clear to everyone? Yeah? Okay. Now, there's an example of using derivatives, concept of technique of derivatives to calculate price elasticity of demand. Now this is something that I'm going to do myself. I'll show you the solution. We don't have to calculate it. But you told me that you are okay with derivatives. So in this test, we will not have anything to do with the derivatives. It will be the next test, test 2 and the final. There will be some questions here.
When is the next test?
It's the next week, Thursday. Yeah. On the yes. Everything up to yes, one sec. Everything up to the point that we covered demand elasticity. So whatever we covered up to Thursday, basically this Thursday will be on the test. So this Thursday actually we're gonna do problem sets, some problems. So you will see what type of questions will be on the test. Yes.
I'm away next week, so I won't be here for the test.
I think two of you now. You may have to take the test when you come back. I'll ask the admin lady here at the Taylor, the 4th floor, I think, or 3rd floor. There's a faculty floor where all the faculty sits. I think there's a meeting room where they should allow you to take the test. I just need to find out when and what time it will be available, and then we will see how your availability matches with that, and then yeah. Yeah, you.
Is the test only like problem sets or?
Yeah, there will be problem sets. Of course, it will be a combination of essay type questions, very short answer essay type questions, and numerical. You have to use a lot of graphs.
All right.
A lot of graphs. So it will ask you graph, explain, indicate, show, things like this. Yeah. If it says explain, so explain it properly, not a one page long description, obviously. Graphs, if you can. You can use different colors to show movements in supply and demand, shifts in supply and demand as well. Okay, let's look at this problem. Now, you may have a slightly different set of slides online because I updated it today. I'm going to upload this version on Blackboard. This is the updated version. We have the following demand curve. Notice that this is quadratic function, p being x. Yeah, it's a quadratic function. So the demand curve will be parabola, something like the one that we had before in the last slide. Yeah, something like D, curve D. So let's solve these questions B, C, D all together in one go. Can you all see the elements on the slide? The small elements and big ones as well? Visible to everyone? The first step is just to work out what the demand curve is by evaluating QD at different prices. Yeah? So when the price is 0, if you plug the 0 into P's here, you will have 60 minus 0 plus 0. That gives us quantity demanded of 60. Do the same thing for 2, 3, 4, 5 up to 6. So, and when you plug in 6 here on the P, then you will get 60 minus 90, that's 15 times 6, plus P squared, 6 squared, so 36 equals 6. And you draw it basically, yeah? Very simple, nothing major. That's what you do as well in the test. You have to show by drawing using the kind of tabular solution. Now, the aim is to evaluate this demand curve at this point where price is 3 and quantity is 24. So we need to find the price elasticity of demand at this point here. I didn't label it, but you can label it as anything that you want, A, B, C, D. So let's say it's point A where price is 3 and quantity is 24. So this is the question number B here, question B. And remember the price elasticity of demand, point elasticity of demand is this formula, change in D over change in P times P over Q. Now, we will apply now concept of derivatives. At point here, one way is to draw a tendency line and work out the slope from there as well. This will be even easier, right? But even easier method is to apply the derivatives for concept of derivatives. So the term here is calculated, this term here, dq over dp is calculated using the differentiation method. So differentiate qd function with respect to p, which gives us minus 15 plus 2p. Yeah? Do we need intermediate solution here? Does anyone need explanation here?
Yes.
Yeah? So we just use the derivatives